Hello everyone and welcome. Today we are talking about the evaluation of multi-agent system. A multi-agent system can pass every test that we have written for them and still be failing in several different ways. These systems are easy to demo, but as we may know, they are hard to trust in production. So in this series, I walk through how they really fail, not the crashes that we usually can get, and also the failure that are hidden and the signals that we can look for them. Let's go into it. There are two ideas that we need to unlearn before we measure anything on the multi-agent systems. A multi-agent system is a pass, not an output. Assume you have a single model app, so probably you have just one output to score, and that may be good enough. But in an agent system, you have a sequence of the decision, which agent has been called, which tool, and in which order. So even for the same question, it may go to the different route to reach to the answer. So in this case, for evaluating a multi-agent system, you can't just score the output, and this is the first thing that we need to unlearn. What is the least useful question that you can ask about your agentic system? So it is, what is our agent accuracy? To justify this, assume that you have two agents, so both reach to the same correct answer, one in 3 steps and another in 30 steps. And it has a lot of the replanning, retrying, and also burning a lot of time and cost for you. So in this case, we can see that they are not the same, and we need to look to the behavior of the agentic system instead of the accuracy of the output in this case. So how do these systems actually fail? There are 4 distinct modes, and one of them is the obvious one. So we will look at them in the next lessons. For failure modes, the first one is the hard failure, which is the visible one and it's the obvious one that you can catch them at the first. The second one is the fragile success, the behavior drift, and also the silent degradation. We will talk about them in the next lessons one by one. The first category is a hard failure, which are the crashes, the error, the exceptions. They are very low and obvious, and you can catch them very easily. To do that, so you need to just have an error monitoring and setting some alerts for the different cases, and that should be enough. Mode 2 of failure are the fragile success. In this case, the answer is correct. So, but the agent reached to that correct answer by accident, or for example, maybe there was a crash, replanning, get the system out of that crash or that failure, or maybe there was the extra tool that has been called that wasn't originally planned by your planner. So, in this case, what is the problem? The problem is that there isn't any guarantee that next time that the system, the multi-agent system run for the same input can reach to the correct answer. So the way to evaluate this mode is just checking the alignment between the plan and executions that the agent system had. The third category of the failure modes are the behavior drift. In this case, for the same question, maybe you have a different execution path, different tools, or the different response steps. So if we imagine, we can expect that for the same question, our agent behave mostly the same, but it's not the case if you have a behavior drift. And also in this case, the different part of the trace may not be wrong, and all of them came as a correct in the logs. So how you can catch it, we need to compare the queries that are similar together and check the cross-query consistency to detect the behavior drifts. We will talk about it more later. The first category of failure that we call it silent degradation is when you deploy your agent into production, and over the time you can see that there are more calls to your LLM, or there are more steps in the agent, or the is taking longer to run, to have them more latency and so on. In this case, you can see at the release time everything was fine, but after release you see a degradation in the performance. So in this case, there isn't any error, there isn't any worse answer, and so on. Just we need to compare the model behavior or system behavior over the time with the baseline that we have and see the terrain over the time. In the previous section, we talk about what can go wrong with your agent and the different failure modes. But here we talk about how serious those failure can be, and we categorize it in the three classes. The class one of the evaluation signal is the functional signals. In this case, something is broken and we need to act now. The second one is behavioral. It means that everything was fine, it worked, but it was suspicious, and how was the problem here. And the last one is a statistical, that we can see that the numbers that we measure, the method that we had are unusual, but it's not means that there is a bug with the system or there is any problem, but we need to keep an eye on it for a trend. So let's start with the class 1, the functional signals. In this case, something is broken and we are sure about it, and there is a very high confidence signals. Actually, there is a task has failure, or the output is wrong, or for example, it skips some critical step, or for example, it's called an API before it passed the steps that it was depends on. So in this case, we can see there is actually crash, there is exceptions, and so on. We need to call someone or block the release and actually make it right before anything else. The second class is the behavior signals. In this case, the agent works, but there is something suspicious. And what I mean from it is that for the same query type, we have a very different execution path. Or for example, you see unexpected tools or agent appear in the trace, or for example, there are a lot of redundant API calls, or the plan diverge many times for the similar input. So we need to see, for example, for the clusters of the similar questions, we have the same issues or not. The third class is the statistical signals. In this case, one of the metrics are unusual. For example, the latency is more than expected, the token usage, or for example, the API volumes are high. So in this case, as it is a statistical signal, we needed to react for just one single spike, and we need to watch the trend, and if we have a baseline, compare with it over time to see how it's changed in the time, and then if actually we see a big shift, then we can react to it. In the next session, we talk about what we actually should measure and where do errors really come from. We talked that don't measure only accuracy in the agent. Here is the 4 domain of the evaluations that we need to do in an agentic system. The first one is to look for the reliability. It means that, for example, we need to measure that the job completes safely. The second one is the error profiling. We need to have a trace and look to the trace and see where the failure starts and how they spread. The third one is the behavior consistency. As we talked before, for example, same input should have the same behavior. And the last one is the unusual cases, and we need to detect the anomalies in the behavior of the systems and the numbers. So we will talk about each of these more in the later in this video. The first thing that we should consider in the evaluating of multi-agent system is that, for example, if we say that our accuracy is 72%, what that means, which agent we talk about in this multi-agent system, or which part or which roles it has. The roles in the components of the agentic system can be orchestrations, it can be planning that give the task for the execution path, and also the supporting, for example, roles is, for example, the context management, the memory, and so on, or the task, for example, the tools, and so on. So that execute the domain task. So in this case, we need to have the different metric for each of the different roles when we measure the accuracy and evaluations in them. As I mentioned, using just one score is not enough for evaluating a multi-agent system, because that's averaging apple and orange between the different component types of that multi-agent system. For example, in the planner, we need a structural evaluation. For example, we need to check the dependency graph between the component in the plan, or for a task agent, we need to check the success rate, the latency, and so on. For the orchestrator, because it appears in every traces and the whole system, actually a low failure rate doesn't mean anything without context. We need to check the context there. So in this case, as we can see, for example, when we say something is failed, one agent is failed, it doesn't mean even that agent has been failed. Is maybe the supporting agent that fit the data to that agent failed before that and give the worse or not correct data for that agent. So we need to consider a lot of different things when we are evaluating a multi-agent system. Let's talk about the causality in the error, in the sense that error don't stay where they start. Actually, they propagate through your network, through your multi-agent system to the downstream agents. So in this case, the agent that has the most error is actually the victim here and not the cause of it. So for example, if you see the agent X is unreliable, then you need to check if, for example, the error in the agent was Y caused the error in the agent X or not. In this case, if you fix the agent Y, then your problem with the agent X also will be resolved. So instead of asking which agent has been failed, it's better to ask where the chain has been started. In this case, if you find the original and see the first component that the failure actually started, then you can follow the downstream impact through your dependency graph. And then if you fix the root cause, probably most of the problem in the downstream will be solved as well. We can check it later. Next, we want to talk about behavior evaluation of an agentic system. In this case, there isn't any error, but the behavior still is wrong. So there is an inconsistency and loops in the system behavior. To define what is a consistency in the multi-agent system, consider this phrase: your agent isn't wrong, but it is inconsistent. It's part of the behavior drift that we talk about it. So assume that for one input there may be several correct answers. But the agent uses different tools, different execution paths, different paraphrasing, and or maybe different wording, different latency metrics you can measure there. So in this case, the answer is correct and there isn't anything wrong, but this is what the people say when they say the product feels unpredictable, even when the answers and the output is correct. And how we measure the consistency or inconsistency in an agentic system? For sure, we don't mean that we need to compare one query to every other query here. So the practical approach here is we cluster the queries, the input based on their similarity metric that we define. So, and we can expect or assume that the samples in one clusters have the same behavior or similar behavior in our system. So in this case, we can measure the content, execution, and performance metrics of the samples in each cluster and then compare them and flag the divergence between those metrics inside of one cluster. And if there is one sample or several samples in each of those clusters that has behaved differently from the other samples of those clusters, then we can flag those clusters. The next category of the behavior metrics are the loops or the methods that are related to loops. Loops actually are the silence killer of the agentic system in the sense that, for example, every step looks correct, there isn't any error, and it appears the system is working, but actually is doing a loop and there is no progress and it's just burning our token. So in this case, standard monitoring is blind to them and we need to have some algorithm to detect those. Here I'm giving you some example of the loops in different parts of the system. For example, if in the planner it can replan the same task repeatedly, and then every time that it's replan it is just slightly different from the previous one and nothing actually move here. In the tool, you call the same API over and over and all of them came true, but it's called several times the same API. Or in the replanning, so you have a failure, you replan, but you have the same failure, and the system goes again to replan and again. Or that's orchestrations loop. It means that it delegates the action to the same path that it had given the previous time. And how we can detect the loops. The good news here is that loops are structural, so it's not difficult to detect the loops in traces. So in this case, we need to look at the traces and extract the sequence of the component there and look for the repeated subpatterns. If we had those subpatterns, then we can compare a new trace with the normal range of those patterns happens in the whole trace and so on, and based on that we can detect the loops in our system. Before I start in the next section, if you like the video, please just subscribe. So the next section is about the evaluations of the planner. So a planner deserves their own evaluation, and we evaluate them in two parts. One is before executing the plan and another after executing it. Another wrong question that we can ask is that did the plan succeed? I'm saying it because the success of a plan may have a different reason. One of them is that the planner actually got it right, and that's the best case, but there are the case that other component may be correctly covered for it, or assume the case that there was an extra step in the planner and so the plan executed and it was fine. Usually we know that the autonomous system lean to hide the bad plan. So one way to mitigate this is that we evaluate the plan before executions. And what we can evaluate before running the plan is that one of them is the selection quality of tools, and another is the structural correctness in the plan that we can look to them later. First check is the selection quality of the planner. Did the planner assert the wrong component for these queries? There are some red flags that we can look for. For example, is there an unknown agent that the planner has been selected and there is any hallucination there? The second one is unreliable agent selection. Assume that for this query there are two agents, one of them is more reliable and that didn't chosen by the planner. And also the last one is the unusual selections in terms that, for example, for the similar question in the past there was a completely different selections of the tools by planner, and that's a red flag. Second check is the structural correctness of the plan. The red flag here are the missing dependency. For example, the step 3 needs the output from the step 1 but it never declared in the plan, or assume that there are secret dependency in the plan so the step can wait for each other forever, or there are the unusual complexity that there are far more steps or less steps in compared to the similar queries or similar cases in the past. Now assume the plan has been executed. We can check the alignment of the execution with the plan. For example, if the plan has the step A, B, and C, but during executions we have one unplanned step D, or one of the step of the plan, step B, has been skipped. So in this case, maybe the output be right, but the plan barely follow. So, and this is a hidden dependency in our multi-agent system that we need to deal with it. There are three different things that we can do between the execution and plan. So for example, is there in a step in the execution that wasn't planned, or is there in a step in the plan that missed during execution, or was there any out of order executions? So we need to know the limits of our planner. For that we need to measure some metric. For example, scores, success, error, latency, and so on per intent. The other thing that we can measure is the replanning pattern. For example, how often that happens and why it happens. Was it because of the wrong agent in the plan, or was the missing a step, and so on. And we can feed all of these to improve our planner and improving the performance of our agentic system. In this section, let's talk about the different classes of methods that we have for the evaluations of the agentic system. There are four types of the algorithm. One of them is pattern matching, that we talk about it, and it is for detecting of loop and structures. For example, when you have a sequence of the action, sequence of the tool, sequence of the agent call, then you can use it to detect those. The second one are statistical outlier. In this case, for example, the number of steps, the number of tokens that you have used, or latency of the system, and any metric that you can think. So if they have a distribution, then you can measure the outlier then and flag them. The next one are the rule-based validation, the one that you know actually they should be happening. For example, the order of some sequence, some checks that you can do, and so on. And the last one are the baseline that we can learn during our operation, and you can look to the traces and see how they behave in a time as well, and look to the trend of them. So your baseline can be also adapted in the time as well. However, it doesn't mean that all of these methods has the same importance. For example, if there is a loop, that means that there is a structural problem in your system, and that has a high priority. The second one is basically the rule violations. For example, something that you are sure that it should be happen, but it doesn't. And the last one that has a less priority, or the statistical signal, that you can wait and look to the trend of them in the time and then decide about them. I also like to talk about the LLM-as-Judge, that we hear about it in the literature and also in the media. So what are they good for? They are good for comparing for example, the responses together. For example, saying A is better than B, and vice versa. They are good for getting the insight or synthesis the insight. They are good for some, for example, classification that we can do. But we should know that they have their own blind spot. And for example, if you measure something that is in the blind spot knowledge gap of that, for example, it is a special domain, that there isn't any or that much public data outside. So in those cases, that's a blind spot of the LLM-as-Judge. Also, there is a built-in bias in the model. For example, they may tend to favor the longer text and so on. And also one thing is here is that the result, the score, are not reproducible in the LLM-as-Judge, and they can differ from one call to another call unless you kind of fix it in your prompt and then having a Rubik and low temperature for it. However, the biggest mistake when you're evaluating your system is that you judge everything just based on one method and one tools. So that's not the case. You need to use a combination of them, and then, for example, a statistical method, deterministic pattern analysis, and so on, and then select using the combination of all the score that you have to evaluate the different part of your system. Another important aspect that we need to consider is that how we want to present our metrics to the stakeholder. Should it be 200 metric or just one number, and so. Let's talk about it. We may have a lot of different type of stakeholder in our organization. For example, they can be ML engineer, engineering lead, or product manager, or executive, and how we want to say to them how our agentic system is working and in productions is different. So in this case, maybe the engineering need to look to 200 metric or a lot of metric to know every detail in the systems. But hiring manager may just need to look to the 3 metrics to see how is the health of the agentic system that has been shipped to the production. But we should know that there are different pillars of metric in one agentic system, that we can't just average the score between them and saying, okay, so this is your average score. So we need to have a different metric for them, even if we aggregate them. There are metrics about the functional reliability, that's saying you, for example, does the task completed without any error. There is a behavioral consistency, which show you does the behavior of system are the same during the time, or for example, if there are similar queries, similar inputs, similar tasks, does the system works consistency in them. There is planning quality, which means that how efficient was our agentic system, and also there are anomaly absence, that everything is clean. For example, there isn't any anomaly in the system. There are 3 depths of metric, as I mentioned. One is composite metric, that maybe be good for the executive stakeholder. There are individual pillars that I took those 4 pillars that we mentioned. Those are maybe good for the engineering league, just as an example, but there are also underlying metrics that will be good for the ML engineering that debugging the system and want to learn and improve the system. One important aspect about the metric is that it should be stable enough that it didn't, for example, fluctuate a lot with a very small change in the system, but also it shouldn't be that much that it couldn't catch anything. So we should have keep the balance between the sensitivity of metric to the agentic system as well, and it's very hard to design. Now that we are almost at the end of this video, I will just summarize some of the concepts that we talk about it. The first one was that in an agentic system, it's very important to look to the path and not the output answer and evaluate the path of the different tools and agents and so on. The second one is that log or error log are not enough for the evaluation. We need also to look at fragile success, drift, or silent degradation of the system. The third one is, for example, we need to consider the role of agent when we score the things, and also we need to look to where the error actually started and then how it's propagated through your system. The fourth one is we need to watch the behavior, the distribution as well, and also consistency and loops in your system. Next one is that we need to look at the different methods when we evaluate our system. We need to look at the pattern, statistics, rules, baseline, or even LLM-as-Judge if needed. And the final one was that depending to who is your audience and who is your stakeholder, we need to prepare the score in a different level and aggregate them in a different level that they have also the meaning, so we can combine all the metrics together when we show the health of the system. And if there is one thing that you can take away from this video, and I can't emphasize on that more than this, is that don't look just to your error. The agentic system is very complicated system, and you need to think about how you want to build your evaluation framework and how you want to evaluate your system, especially when that agent is working in the production and we want a consistent behavior and acceptable behavior of that agent through the time. And this video was based on a series of notes on multi-agent system evaluation that I posted on LinkedIn, and it was based on my own experience. If you find this video helpful, subscribe to my channel Multi-Agent Academy and follow me on LinkedIn, which I put the link below in the comments.